Imagine boarding a sleek bullet train in Beijing, sipping your coffee, and before you even finish an episode of your favorite show, you arrive in Shanghai, over 1,300 kilometers away, in just 4 hours. This isn't a vision of the future. It's China's reality. With over 40,000 kilometers of high-speed rail, enough to circle the Earth, China has built the most advanced and extensive railway network in history. But how did China accomplish this colossal engineering feat so quickly? The answer lies in a mix of bold vision, cutting-edge technology, and relentless ambition. And the story behind it is nothing short of mind-blowing. The vision: why China went all in on high-speed rail. In the late 20th century, China's transportation system was at a breaking point. The country's economy was growing at an explosive rate, but its infrastructure was struggling to keep up. Roads were clogged with traffic, domestic flights were expensive and inefficient, and traditional railways, many built decades earlier, were slow, outdated, and overcrowded. With over 1.4 billion people and a rapidly urbanizing society, China faced a daunting challenge: how to move millions of people quickly, safely, and efficiently across vast distances. The Chinese government saw an opportunity. Inspired by Japan's Shinkansen and Europe's TGV, leaders envisioned a nationwide high-speed rail network that would connect major economic centers, boost regional development, and reduce travel times dramatically. The goal was not just to modernize transportation, but to reshape the economy itself. A well-integrated rail system would encourage investment in second- and third-tier cities, allowing businesses to expand beyond traditional hubs like Beijing, Shanghai, and Guangzhou. This, in turn, would help reduce economic disparity between urban and rural regions. Another key motivation was reducing reliance on air travel and fossil fuels. China's domestic airline industry was growing rapidly, but airports were becoming congested, and short-haul flights were proving inefficient. High-speed rail, running on electrified tracks, offered a greener alternative. It could move far more passengers per hour than airplanes, with lower carbon emissions and greater reliability. Unlike air travel, which is affected by weather delays, high-speed trains could run with near-perfect punctuality. However, in the early 2000s, many skeptics doubted whether China could pull it off. Critics raised concerns about the massive cost of such an undertaking. Could China afford to invest billions into an unproven system? Would people actually use high-speed trains when cheaper, slower options were available? Despite these doubts, the Chinese government made a bold decision. They would go all in. They secured state-backed loans, developed domestic expertise, and brought in the world's best rail technology through strategic partnerships with Siemens, Alstom, Bombardier, and Kawasaki. By the mid-2000s, China was no longer just a student. It was starting to outpace its mentors. What followed was one of the most ambitious infrastructure projects in human history, one that would completely transform how the world viewed rail travel. The engineering marvel: how it was built. Building a 40,000-kilometer high-speed rail network in just a few decades was an engineering challenge unlike any other. China's approach relied on cutting-edge technology, rapid construction methods, and precise planning, allowing the country to build the world's most extensive and advanced railway system at an unprecedented speed. From bullet trains to earthquake-resistant tracks, every detail was carefully designed to maximize efficiency, safety, and durability. Advanced railway technology, bullet trains, and maglev systems. China's high-speed rail network is powered by two main types of trains: conventional high-speed bullet trains and magnetic levitation, maglev trains. Initially, China imported high-speed rail technology from companies like Siemens, Alstom, and Kawasaki. However, within a few years, Chinese engineers mastered the technology and developed their own high-speed trains, making them faster, more efficient, and tailored to China's unique landscape. The Fuxing series, introduced in 2017, became the world's fastest commercially operating high-speed train, reaching speeds of 350 kilometers per hour, 217 miles per hour. Unlike earlier models, which were based on foreign designs, the Fuchsing trains were 100% domestically developed. These trains feature sleek aerodynamic designs, lightweight materials, and state-of-the-art energy-saving systems, tunnels, bridges, and earthquake-resistant tracks. China's vast and diverse geography posed a massive challenge for railway engineers. Unlike Europe or Japan, where high-speed trains run mostly on flat terrain, China had to build tracks through mountain ranges, rivers, deserts, and earthquake-prone zones. To overcome these obstacles, engineers relied on a combination of tunnels, bridges, and elevated viaducts, ensuring a smooth and direct route for high-speed trains. More than 90% of China's high-speed rail network is built on bridges or elevated tracks, reducing land acquisition issues and allowing trains to maintain high speeds without being slowed down by uneven terrain. The Danyang-Kunshan Grand Bridge, stretching 164 kilometers, 102 miles, holds the record as the longest bridge in the world. Meanwhile, high-tech tunnel boring machines, TBMs, allowed China to carve tunnels through mountains at record-breaking speeds. Safety was also a major priority, especially in regions prone to earthquakes. China developed shock-absorbing track designs, reinforced concrete structures, and an AI-powered monitoring system that detects seismic activity in real time. If an earthquake is detected, the system automatically halts all trains within seconds, preventing potential disasters. Prefabrication and rapid construction. One of the key reasons China was able to build its high-speed rail network so quickly was its use of prefabrication. Instead of constructing everything on site, China built massive railway components, such as track slabs, tunnel linings, and bridge sections, in specialized factories. These pre-made components were then transported to construction sites and rapidly assembled, dramatically reducing construction time and labor costs. For track installation, China used automated track-laying machines, which could lay up to 5 kilometers of track per day, a speed unmatched by any other country. Prefabricated modular bridge sections were lifted into place using giant cranes, allowing entire sections of the railway to be completed in days instead of months. Once operational, the network is maintained using AI-driven monitoring systems, drones, and high-speed cameras that constantly inspect tracks, bridges, and tunnels for defects. This allows China to ensure near-perfect punctuality and safety across thousands of kilometers of track. The speed factor, how trains reach 350 kilometers per hour and beyond. China's high-speed trains are among the fastest in the world, regularly reaching speeds of 350 kilometers per hour, 217 miles per hour, with future models pushing past 600 kilometers per hour, 373 miles per hour. Achieving such high speeds requires more than just powerful engines. It involves cutting-edge aerodynamics, advanced track systems, and AI-powered safety networks that ensure smooth and efficient operations. Aerodynamic design, the science of speed. One of the biggest challenges of high-speed rail travel is air resistance, which increases dramatically as speed rises. To overcome this, Chinese engineers designed high-speed trains with sleek, aerodynamic noses inspired by nature. Some models take inspiration from the kingfisher bird, known for its ability to move through the air and water with minimal drag. The Fuchsing series, China's latest generation of bullet trains, features an elongated, pointed nose, reducing air resistance and allowing for smoother airflow. The body of the train is made from lightweight aluminum alloys and carbon fiber composites, ensuring high strength while keeping weight to a minimum. Underneath, the train's low-friction bogies, wheel assemblies, and advanced suspension systems help maintain stability at extreme speeds, preventing excessive vibrations and ensuring a comfortable ride for passengers. Every design element is optimized to minimize energy consumption while maximizing speed and efficiency. Maglev versus traditional steel-on-steel tracks. China operates two main types of high-speed rail systems: steel-on-steel, traditional, and magnetic levitation, maglev. Each has distinct advantages, but maglev is poised to revolutionize future travel. Traditional high-speed trains, such as the Fuxing and CRH series, run on steel tracks using electric traction motors. These trains achieve high speeds through precision track engineering, low-friction wheels, and advanced suspension systems. While they still experience some friction between the wheels and rails, China has significantly optimized track smoothness and minimized curves, allowing trains to operate efficiently at 350 kilometers per hour. Maglev technology, on the other hand, eliminates friction entirely. Instead of wheels, electromagnets lift the train above the track, allowing it to float and move forward using magnetic propulsion. This allows maglev trains to achieve speeds far beyond conventional rail systems. China's Shanghai Maglev, launched in 2003, remains the fastest commercial train in the world, traveling at 431 kilometers per hour, 268 miles per hour. In 2021, China unveiled a 600 kilometer per hour maglev prototype, which could cut travel times between major cities to a fraction of what they are today. The biggest limitation of maglev is the cost. It requires entirely new infrastructure, unlike traditional high-speed rail, which can be built alongside existing rail lines. The economic boom, transforming China's cities. China's high-speed rail, HSR network, has not only revolutionized transportation but also reshaped the country's economy in ways that few could have predicted. By connecting cities, cutting travel times, and making mobility more accessible, HSR has fueled economic growth, business expansion, and urban transformation. From GDP growth to job creation and real estate booms, the impact of high-speed rail has been nothing short of a game changer. A game changer for tourism, trade, and job creation. Tourism in China has exploded thanks to high-speed rail. Previously, long and expensive travel made it difficult for people to explore cities outside their immediate region. But with HSR reducing journey times dramatically, such as the Beijing to Shanghai trip from 12 hours to just 4, millions of tourists can now visit faraway cities for weekend getaways, festivals, and business trips. Popular tourist destinations such as Xi'an, Chengdu, Hangzhou, and Guilin have seen a surge in visitors. Local economies have flourished as hotels, restaurants, and cultural attractions benefit from the influx of travelers. Many historical sites and smaller cities that were once overlooked have now become major tourist hotspots, contributing to regional development. The high-speed rail boom has also created millions of jobs across various sectors. The construction phase alone employed millions of workers, from engineers and technicians to laborers and suppliers. Once operational, the network required station personnel, maintenance teams, customer service workers, and train operators, further boosting employment. Global influence. China's high-speed rail expansion. Worldwide, China's expertise in high-speed rail has not only revolutionized domestic travel, but is now transforming transportation systems across the world. From Africa and Southeast Asia to Europe and Latin America, China is actively exporting its rail technology, engineering expertise, and financial resources to build high-speed railway networks abroad. A key driver of this expansion is the Belt and Road Initiative, BRI, a massive infrastructure strategy designed to enhance global trade and strengthen China's geopolitical influence. However, this aggressive expansion has sparked intense competition with established railway giants from Japan and Europe, setting the stage for a battle over global high-speed rail supremacy. China has positioned itself as the world's leading builder of high-speed rail outside its borders, leveraging its ability to construct rail networks quickly and at significantly lower costs than Western competitors. In Indonesia, the Jakarta-Bandung high-speed rail, Southeast Asia's first, was built with Chinese technology, cutting travel time from over 3 hours to just 45 minutes. The future of China's high-speed rail. China's high-speed rail network has already revolutionized domestic transportation and reshaped global infrastructure. But the country's ambitions are far from over. As China continues to expand its network beyond 40,000 kilometers, its future plans include even faster trains, cutting-edge technological innovations, and a broader global presence. The next phase of development will focus on enhancing speed, efficiency, sustainability, and international connectivity, positioning China as the leader in next-generation high-speed rail. China's high-speed rail expansion is also becoming increasingly eco-friendly as the country pushes for sustainable and carbon-neutral transport solutions. Additionally, China has proposed an Arctic high-speed rail corridor that would connect China with Russia and potentially extend into Northern Europe, creating a new global trade route. One of the boldest proposals is the idea of a China to America high-speed rail line, which envisions an ultra-long-distance railway that would travel through Siberia under the Bering Strait via an underwater tunnel and into Alaska before reaching mainland North America. Although this concept remains purely theoretical due to political and financial obstacles, it demonstrates China's vision for high-speed rail as a global transportation revolution. Despite these ambitious goals, China's future high-speed rail expansion faces several challenges. The massive costs associated with maintaining and expanding such a vast network continue to raise concerns about financial sustainability. While China has successfully funded its rail projects through government-backed loans and state-owned enterprises, some high-speed rail routes struggle to generate profits, particularly in less populated regions. Additionally, geopolitical tensions and trade disputes may impact China's ability to secure international rail deals, particularly in regions where Western nations and Japan are competing for influence. China has transformed what once seemed like an impossible dream into reality, revolutionizing modern transportation at an unprecedented scale. No other country has built such a vast and efficient high-speed rail network in such a short period, connecting cities, boosting economies, and reshaping how people travel. As China continues to push the boundaries of speed, technology, and innovation, the question remains, can other nations keep up? Should the rest of the world adopt China's high-speed rail model to usher in a new era of ultra-fast, sustainable transportation? Let me know your thoughts in the comments.